please.
Thank you. So I was going to say, who wants that one? A lot of confusions. Thanks.
So we can start the question and answer session for all the presentation that were delivered this morning on eVTOL. You have a microphone in the room, and you have to just to raise your hand if you want to ask something. And the other option is to use a Slido. It's the same system that we used yesterday if you prefer to ask your questions through the system, and they will be displayed on the screen. Yes, one question.
I'm Mike Price from the UK Civil Aviation Authority. The question's to Richard Brown, who I can see you behind there. Has your work looked at any more complex interactions with the spacing of the rotors, the propellers on eVTOLs? To me, raise possibilities of upwash effects, fountain flows, these kinds of things. Have you looked at that and forces and moments that result that cause all sorts of control problems?
Thanks for the question. Can you hear me? Yep. Good. Yeah, that's a very good question. We know that there are effects of the detail design on, first of all, the vortex ring lobe shape, and also on the outwash geometry that's caused by these sorts of vehicles. So the question is, have we specifically done any work on that? And the answer is yes, quite a lot. There's still a lot to be done. I can refer, if you see me afterwards, I can give you my website details, where you'll find that a paper which you can download, which deals in a lot more depth with the interactional aerodynamic effects, which I wasn't able to include in this particular presentation, but we've done a lot and written up quite a lot on that. Very important subject, yeah.
Hi, I have a question regarding the machine learning. So basically, as far as I understood, is that the system is working at the moment only in VFR. Is there a range in which it can work? Because it comes from CAF-OK to zero visibility, and is the camera working in 360 degrees or only in the outer-looking way of the pilot?
Yeah, that's a good question. For the current applications, we decided to start with the VFR just because it's like more visible and it's easier to integrate, and we get more data sets to do that. The applications that we are doing right now, the best application we have is covering the front half a bit behind, I think in total about 220 degrees or something, and then down. That's the starting point. But right now we haven't yet done the 360 degrees augmentation, but eventually those are the plans. We want to start small, make sure it is certified. There is a lot of questions from the public if it's possible to certify an AI in aviation, and it will come later. I hope that answers the question.
You have a question in front?
I have a question also to Ramanujan. At DLR, we did more than 10 years ago work on object identification using cameras. And at that time, at least, it was a big topic to be real-time capable, because you need a lot of computing power to make sure that you really can scan all those pictures, all those camera views, and make a proper identification of the objects. And this got even worse when your own flight speed was increasing, or when the speed of the objects, the airborne objects you try to detect, was increasing. Is this still a topic?
Yes, it certainly is a topic. But first of all, I want to make it clear. We are talking about, I'm sure you know, I'm talking about offline supervised learning. So the learning doesn't happen during flight. So the learning of the data training and the whole proof of the model happens offline before it is certified or before it's installed. At the moment, for the project that we are running with the 3 cameras, we are running into the margins of what the computers, the equivalent of GPUs can provide in terms of processing speed. But there are new chips coming in the market, mainly in gaming, in the gaming industry, which we hope to make use of to also get the proof to certify, to qualify aerospace. But that is something that has to grow as the need grows in the future. But yes, there is a concern. I'm not a hardware engineer right now, so I cannot go into the details of exactly what, but yes, we are looking at that. But yes, that is a factor.
You put one keyword on one of the slides, which was the completeness of the data as a basis for certification. Can you just give some words on this? Because for me, it's not obvious that you can guarantee that whatever data set is complete.
No, I'm not sure exactly which slide you're talking about, but basically, the most important thing is the data distribution covers the real world as complete as possible. You're right, it's impossible to cover every kind of object, but that's the challenge in any such application. But my colleagues can probably explain it better, but we have the basis from the learning theory with statistical reasoning and probabilistic distribution to show that the data distribution that is used very well defines the outer space. And the fact that even if the performance rate for one image may be even if it says 90% success rate for one image, it's not the same as saying we need 10 power minus 9 for a level A system. It is or successive images when you keep looking at an airstrip runway at one image, even if you fail to recognize once, but in the next frame you will see it. And over a period of time with the successive frames, the confidence level increases, and that's how we can show the required safety targets. But data completeness is a challenge, but we can prove that it is still possible to cover as much as possible in terms of data. Thank you.
This might be quick because it's related also. Means of compliance, I was actually a bit curious. You mentioned that there were PhD theses related to this topic, so maybe they go further into this. But how far have you gone into information? What will be acceptable as you go along this W as means of compliance?
That's a good question. There is one of the slides I showed. EASA released first usable guidance for artificial intelligence machine learning applications last year. And this document defines how the whole subject is structured, and it gives a lot of objectives in terms of trustworthiness, explainability, and many other topics of AI. And these objectives are the ones we aim to follow. And although this is not yet an established specification, this is the best document, the best set of guidelines that we want to follow. And in the current project that we are running, we have agreed with EASA and FAA. The project is with FAA, and EASA has a concurrent validation for this project. We have agreed with them that we are going to follow these first usable guidance. So that document is the best if you are looking for some guidance, and it gives very clearly what all goals we need to achieve and what kind of compliance we can show. Thanks.
We can maybe take one of the questions on Slido because it's related to the subject, same subjects for you. Have you seen any example of visual artifacts affecting the see and avoid function similar to what was seen in automotive cases, such as misidentifying?
That's a good question. I think not so many. The thing is, it's a bit easier in aerospace for such machine learning compared to automotive, because there are far too many objects on the road and far too many different kinds of people and animals and rocks and bicycles riding or bicycles fixed on top of a car or behind a car, camper van. So it's much more challenging for autonomous driving to implement that. In terms of artifacts, we did have a situation where in one of the trials recently in Brazil, while flying, a lot of the in the sea, a lot of the boats that were there were identified as targets. So it was an interesting object, but at that time we were not mature enough to classify it as a ground target or so on. But artifacts, I am afraid I cannot, there is no example I can provide. So far we've been good.
Thank you.
Hello, my name is Claude Vichard. I have a question to Richard concerning recovery techniques on the eVTOL. Obviously, there is no recovery applicable there. How we can protect the passenger and the third party in a vortex of one of the rotor? Have you a solution?
Yeah, thank you, Claude. That's, again, a very good question. The talk almost dealt exclusively with how to get into trouble and very little with how to get out of trouble again. And if I look at the Vimeo screen here, there's another question which I can perhaps answer at the same time to save some time, and that is, have you seen the same effect on smaller UAS? And the answer is an emphatic yes. Yeah, this is scale-independent stuff, so you see it no matter whether it's a big helicopter or whether it's a tiny little quadcopter. The interesting thing about UAS, though, is that in a way it's leading the technology towards the manned or towards the, especially towards the autonomous aircraft, but also it sheds some light on the piloted aircraft that we're going to see as well, in the sense that not every one of these aircraft is going to have a Claude Vichard at the controls who's seen this state 1,000 times before and has an appropriate method for exiting the vortex ring state. Somehow, especially in an autonomous vehicle, we're going to have to encode Claude's knowledge in some sort of autonomous system which could not only recognize the signs of the onset, but perhaps can also cope in a properly strategized way with the fact that the aircraft, through some atmospheric phenomenon, let's say, has managed to precipitate itself into the vortex ring. And I think that's a real challenge. That's where aerodynamicists and control system theorists and artificial intelligence specialists and robotics guys can really get together to make a real difference in terms of the safety of some of these vehicles.
I have a question to Richard. Can I ask?
Yes, please go ahead.
Without getting into details, if you were to bet on the possibility of this whole eVTOL market taking off, are you still positive about it with all this considered?
How much time do I have? Look, I'm going to say something that's going to sound terrible, and then I'm going to have to explain myself out of the hole that I've dug myself in, because I see the eVTOL community as dinosaurs. Now everyone goes. Dinosaurs in the sense that it's an evolving species trying to fill an ecological niche. Now, what happens? The environmental pressures on the dinosaurs changed. They developed into these crazy morphological weirdnesses, in our case, with multiple wings and rotors and whatever. But as the competition kind of takes hold and things kind of get sorted out, the sort of more outlandish things will perhaps lend insight genetically into the next generation of vehicles, which will improve and improve and improve. And as long as we follow that genetic path through the technology, I think we're on safe ground. The problem is when the meteor comes. Okay, and what is that meteor going to be? It's going to be when somebody, maybe in this room, but hopefully not, somewhere out there, is going to do something crazy because they don't understand the physics or they don't understand the environment they're operating in. And one day, one of these vehicles is going to come down on your neighbor some way. And that's what really, really worries me. It's the fact that in this industry, sometimes we cannot afford the hype that there happens to be. We need to have a level-headed, technologically based approach, which is founded on the most detailed understanding of the aerodynamics and the machine learning and all the physical disciplines that come into making these vehicles a success. And that's what I challenge the industry to do, to let go of the hype and start to actually engage in this post-honeymoon phase of getting these vehicles into the air in a properly regulated, accredited, sane and sensible engineering fashion. Okay.
Thank you.
Does that answer your question?
Yes. Okay.
I think we can take one or two questions from the room before going for lunch today.
So my name is Alex Sherry. This is a question for John. My background is commercial fixed-wing aviation, so maybe I'm a bit out of place here. However, one thing that I can bring from there is the safety, where we tend to boast about our safety record, but when things do not go so well, we tend to keep everything in silos. Obviously, this needs to change, especially for something new as an eVTOL in the eVTOL market. What do you think can be done? And do you think the regulator must come in, especially there's so much information that's being kept internally in companies? What do you think can be done in that case?
I think particularly if we're going to deal with these horizontal organizations where perhaps an eVTOL manufacturer also becomes an operator, contracted to a city to provide a transport service, there's going to need to be some form of organized sharing in the industry. This is done in the commercial aviation world. You have flight safety committees which operate under, say, Chatham House rules, where the operators get together, they close the door, they exchange information under a confidentiality agreement. And that way, the learning is a total system learning, rather than having to learn something in Singapore, learn something in Paris, learn something in London, and realize that you have the same failures occurring across the globe. So I think the industry itself has to come together and get over, yes, this initial phase, yes, it is the dinosaur phase, isn't it? One or two of them are not going to make it. But those who mature in the UAM, AAM world are going to have to find a way of sharing some of their safety intelligence for the bigger picture. Because if they're going to maintain public confidence, they're going to have to do use the same techniques as commercial aviation have used.
I propose now we stop with the question so that you have about 1 hour for lunch today. If you have remaining questions, I'm sure the presenter will remain and you can go and discuss with them directly. Yeah. So thank you very much for being there today. We make a short break and back in the room at 1:15.